So here we can now start plotting. This is a MATLAB command window. So next 1 or 2 session we are going to play on the command window only, and later on we are going for a script programming separately. So in this case we can create an x-axis, so in which you need to start with a 0, then you need to start you need a 0 to 4 pi, and that to be 100 space 100 points you wanted. So in that case what you can provide line space as an one function, okay, which will divide the total number of points from 0 to 4 pi. Pi is in a constant, inbuilt constant into the MATLAB. I want 100 number of points between these two. So that is what specifically you can write. Means if you enter this, you can observe. So it is going to create total 100 numbers in row matrices. It has 100 numbers it has created. So now we want to plot it y is equal to. So I can have a sine of x. So this is one graph. I want to plot it. So I'll put up a semicolon to avoid the display of all the values of y. And similarly, I will have a y1, which is exponential minus x. I will provide here it is a 0.0 or 0.1 into x multiplied by sine of x. Okay. So when you enter this, there it will return some error. The reason for this error you should understand, because it is x is an array. You are taking a sine of x means it is again creating one more array, and this array is multiplied with this another array. Means this is an exponential. Hey, x is an array. It will multiply 0.1. It will put into the exponential. This will create one more array. So two arrays cannot be multiplied because it is a matrix. It is not in a matrix multiplication, but ultimately first number of this array, first array, and first number of this to be multiplied. That is what it is called as an element by element multiplication. That is possible by using a dot operator. In this dot operator, what we can do it, we can put up a dot and you can now work out. Means this is not going to show up any kind of an error. Now we are going to have a plot as a one command, which is x versus y. For this we want different symbols for it, so which we have seen in this PPT. So you want a solid line, dashed line, or dotted line. So in that case what you can do, x versus y. Now I need to specify this into the quotes. That is this quote we are going to use it. I am going to provide a dash line, so I can now provide 2 dashes. It will create 2 dashes for first line. Then another one, x versus y1. I want to have the next one is I'm going to plot it with some other symbol, maybe a dotted line or solid line. Defaultly it will start with a solid line. There is no issue in it. But when you want to start with a dash dot line, so obviously you need to provide the same concept here, dash, and then put up a small dot. It will create a dash dot. That is typically in graphics we use that is dash dot kind of center line kind of a symbol. Then you can just put this. You can observe this plot. So here you can just observe there is a dash as well as dot is there. Here it is a completely dotted line and kind of things are there. So now similarly you can have now given a x label, and x label I will say it is an x coordinate. Okay, then I will enter it. It will x label will display at this location, x coordinate. Similarly you can have a y label. Okay, we'll change it to the y coordinate. Okay, then legend, I will provide a first legend is my y, second legend is my y1. Write it, because this is nothing but a typesetting. I am going to tell you how to do is this typesetting. This is a typical latex language is used here for creating a different type of symbols and kind of things. So this is what in a legend it will display at this location once you enter it. Okay, Then you want to give on a title of it. Title, obviously it will be on the top of it, so you can give on this is my first plot. Okay, you can give the name of the title. Then you want to now give us some text also. That is what a text is one command. Now in this text, make sure that whenever you are using a text, you need to provide 2 points. One is x and another is y. So if I say it is a 0 0, okay, then means it will start with a 0 0 location here, and then I will write the plot first. I will write as a title for this, and I will close it. You can just see here. So this is my 0 0 location. It has started writing here. Now if I change the location of this, I can have now 10 10. I will do it, so that you can just observe how the location of this changes, so that wherever you want a text, you can put that text into this. I just close down, and once again I will just do it for you. This is what on a plot. Okay, then I will provide in a text 10 10. Here 10 10, there is no location as such. See here it is a 0 0, and here it is in a 1. Here it is in a 0, and it is a 14. 10 10 means this is a y-axis is a 10, x-axis is a 10. So it will somewhere out of this entire circle. That's what it is not showing it. So instead of that, I can now have I'll say it is in a 0.5 as in a location, and I will provide in a 10, means somewhere it will display at this location. So we can have this. Okay, it should come. Okay, maybe some error is coming. Anyway, so there is this is one way of putting a text onto the graphical window. Another one is you can use a G text, that is a graphical text. You can use it. In graphical text, I can have a plot first. I will say plot first, and then I will enter it. What it happens in this graphical window, it will immediately create an arrow, that is a plus sign, and whenever you want to enter that text, you can just put it. This is my one plot. This is my text location. I can provide it. So this way you can now use a plotting purpose. Another one, after this plotting, I will just go on to the next part of it. So I will just show you one more thing. Here it is most important is one more thing is that subplot. In this subplot, what it creates, this is my picture, that is my figure. So this is entirely a big figure, and on this figure I am going to divide this figure for multiple plots. Means I want to have one plot for this, second one, third one, and I want to arrange it into kind of a matrix. So for that purpose, this typical plot is used. So we'll now start with a subplot. So I'll just CLC, and then already we have two variables. We'll now create few more variables. I will say it is in a y2 is equal to sine of x into, I'll say it is in a cos of x. Okay, here I need to provide in a dot here. Okay, then I will end it. Then I can have a y3 as in one more plot, which is sine of 0.5x multiplied by cos of x. This is total 4 different plots I want to do it. So I will start with a subplot as in a command. In this subplot, I want to have a figure. I will, before going for this, I can now put it in a figure as in a 1. So this figure, on this figure I am going to divide this into 4 quadrants. Means this is my first quadrant, and then second, then third, and fourth, like this. So for that purpose, what I can do, I can now have a subplot as in a command. This subplot, first of all, how many rows and how many columns you want to divide, that is a 2 rows 2 columns. And what is the location of it means, so I want to have a first here, then here it is in a second, then third and fourth, like this. So this is my first one, and then I will enter it. So obviously it will create a plot. Now you need to tell what you want to plot it. Now you have created one array for it. So now I can have a plot x versus y. So this plot will be displayed onto this graph. Okay. So I'll now enter this. You can just see this. So you can provide an x label, then x coordinate, then even you can have multiple commands in a single line also. You can have a y label, comma, you can use in a comma. So then I will say it is in a y. Then again I want to have a legend, then this is y. Like this I can go on adding more and more commands. Okay, then it will show you all this x versus y, axis something. Now I want to go for another plot, that is subplot. 2 by 2 is my complete description of this. Then I can have a second location I want to plot it. So that second location is this. So this second location. Then again I will have a plot here. I will change the plot to the y1. Okay. Then this is now my second plot. Similarly I can have a plot third location. So it will display third. Then I can have a plot y2 here. It will display the y2 here. Similarly I can have a last one. So here instead of 2 I will have a fourth location. Sorry, 4. And then last plot I can have y3 as a last plot. So this is what the way you can create multiple plots into this, and you can enjoy in a single plot you can have multiple plots. So this is one way by which you can go on using this plotting into this. Few more features I can show you into this. So when you are going to have a plotting here it is an edit arrow is there, edit the plot, there is a zoom is there, the zoom out is there, then there is a pan and all these commands. If I use a data cursor, I can use a data cursor, I can mark it anywhere. So once I mark, it will show you some data point, what are the location of it, what is x location, what is x y value and kind of things. Anywhere I can click it into the plot, I can get these values quite easily. So another, if I click onto this edit button and then I want to, so you can just observe these are the black 4 squares, you can observe it onto this plot. This indicates your plot is now editable, you can edit it. Now I can double click. Okay, double click means it will start opening this editor for this plot. In this editor plot you can now select whichever the line you wanted. This is the line. Obviously in downward place you can observe it. It is going to change dynamically the things. So here you can give the figure name. This is my figure 1. Okay. So it will display here figure 1 as this. Previously only figure 1 it was showing. Along with this I can now, this is my first subplot, I can write it. So it will display the first subplot here. Then I can now color map whichever I want to decide, I can go ahead, but so color map will be mostly used for kind of a 3D kind of plots. Here I can have a figure color, I can provide a completely white I want it and completely red I want it, whichever I want it. I can provide this type of color also, I can provide yellow color also, then green color also, whichever the color you want it, I will make it completely white. Then I can now select one of it, and then I can even change the display name, and it will take automatically because you have plotted it automatically. Here you can decide what type of line you want to go for it. So this is one. Marker you can decide, I can now decide type of marker. So I can reduce the size of it. So this is also possible, quite easily you can do all this. And you want to fill the marker, this is what in a marker you can face. You can put it black color as in a fill, or red color as in a fill, or something another color also, green color also you can fill it. And you want to give a color for the line color, so I can now blue color I can connect it. And here you can change the size of this. This is these are two are, this is fill color, and this is what are the filling you are going to do it. It is a circle you have selected. So around this circle there is one line, and that line is you are going to give a blue color line. If I put upon a black, it will show you black color line, and this is a fill color. So similarly you can increase in a size of it, maybe in a 2 size, 2, maybe in a 4, like this you can increase or decrease. So I'll put it 2 as in a size. So same way here for also, I can now here select a dotted line with a square and with a smaller size, and I want to fill it with the red color with this. I will provide in a size as in a 2 size. So this is what the way you have plotted it. So then third way, so once you've done it, next come to the another one. I will now go for dotted line. I will increase the size to the 2. I will give a symbol as in a star here. Then 2 size, or I can go for a larger size so that I can quite easily use this. Then here also you can go for that dot and dash type of line. I can increase the size, or I can provide an appropriate symbol also. I will now use this symbol. I can decrease the size of the symbol like this. So this is what the way you can create plots, and you can edit in a 2D plot anytime. So this is one option, we have seen it. Now I want to go out of it. So obviously I will just close down this, and I will minimize or undock. I will do it, and I will close this. Now we are again back to this place. Then you want to have some tools, what way I can use more tools into this. This is what in a first edit plot we have seen. We can zoom in, and you can look into the appropriate zoom in. I want to see the particular data points, I can zoom and look at those data points also. And if I want to zoom it up the size only, it will now only plot from this point to this point like this. This is also possible. It will automatically adjust the axis. Another one is you can set the legend. You can put the title here. It will show you the title also. It is taking time because it is online, and that's what the cursor is continuously blinking. So similarly you can provide a legend for it. Automatically it has created a legend. So here again I will provide a legend for other places also. Okay, so I'll click onto this, and I can go for legend for all the places. I can now select this plot, and I will go for legend. I will say it is a legend for this. Then you can also you can go on creating in a certain line. You can plot a line also. I want to have a line, and I want to have an arrow also. You can use an arrow here to indicate, and you want to give the name for this is a sign plot or something. I want to have a text box here. I can write here text, this sign plot. I will write sign plot. Okay, so similarly I want to now adjust the size of this. I can adjust the size, or double click. I can change the property of it. I don't want to line, and that is what you want to do it. So it will now it will not show a square of this. Similarly you can have here text arrow. So text arrow means this is what a text arrow. It will create a text arrow. You can go on writing it. Once again I will click it so that you can quite easily see it. So I want to have a text here and I want to locate the arrow. This is exponential plot, I write exponential plot. Okay, so it will, now I can have locate or I can relocate anywhere. So similar fashion you can have a double arrow also. You can both the side there you want to show up something distance between this, and you can use this as a double arrow anytime. Then the text we have seen, we can provide in a rectangle also, ellipse also. You can set the axis also. You can click onto this, it will now decide the axis also. Okay. So then again here there are certain tools which will we will look at into further part. So this you can just go on exploring, you will come to know how to use this all tools for this. Along with this, in this tool there is one more option where there is two options, very important options. One is basic fitting and another is data statistics. In basic fitting you can decide what type of fit you want to do it. So before going for this I will just close down this figure and then we'll move towards a simple plot. I will clear all CLC. Okay, then I will have an x variable from maybe 0 to 100 something. Then y variable I will have a y, I'll say it is I will plot in a line 10 into 10 plus 10 into x. This is a simple line plot, but I need a random numbers for this. For that purpose I will use a random as a function. Okay, don't. So we'll just plot this, or I can have rand 1 as to 100 as 100 random numbers. Then I will have a plot x versus y. So okay, sorry. So I need to just check it out. What are the sizes? X is having a 101 size, y is having a 100 size. So obviously I need to change one of it. So I can go for here, instead of this 0 to 100, I will say it is in a line space 0 to 100 with steps of 101. So this will create an x vector, and then I will have a random vector. This is also one of the way. Another way, I can now, instead of putting this 100 or something, what I will do, here I will determine the length of this x. Means I am going to use a length as a function which will take x as an input, that is the entire array. It will determine what is the size of it, maximum size. So it will give that value. So I can now have a y. Then again I will put up a whose. I will just check it out. Both is having the same size. Now I can quite easily plot it. Then I can have a plot x versus y. This is what we got these numbers. But these numbers are very randomly varying. So obviously what I will do, I will give instead of line connections, I will provide a star as a symbol for this, and I'll plot it. So you can see all these numbers are there. So now I want to fit this curve, or I want to see the trend of it, what is within a trend or something. So once again you can have a smaller size rather than going for more number of size. I will go for only random size, not more than 10. I'll just plot x is here, it is I will go for 10. Then y will be length of x. Then I will have a plot. So these are the few 10 numbers. I want to fit the curve out of it. So for that purpose I will have a grid on. I will do it. And now I look into the tools here. So in this tools, now you can use a basic fitting for it. So this basic fitting will be used for fitting this whatever the data. So there are two ways by which you can fit it. One is interpolation and another is in curve fitting. In interpolation, what it happens, it will take a first point, then second point, then third point, fourth point, like this. It will connect it. That is what called as an interpolant. And another one is I want to fit the curve. So if I click onto the straight line, it will fit this entire curve, straight line curve. Means it will determine that minimum error and kind of things. That is what it does. Then you can also see the plot how much amount of residual at each point. You can observe this is my actual fitting data, and this data is this much distance is there. So along with this basic fitting, you want to see the equation for this. You can see the equation on the plot here, that is 0.4000646 into x something. So this is what an equation. Also you can change the digit. If you want to go for a higher digit, you can go for fifth digit, like this. You can decide it. Then also you don't want a residual plot, it will remove the residual plot. Then click onto this. You can just observe what are the. This is a simple straight line fitting. That's what it is going to show you, this P1 and P2 equation and residual. Then similarly you can have another fittings, that is a quadratic fitting also, then cubic fitting also. You can go on fourth polynomial fitting. So I will just go on doing one by one rather than doing this. Okay, now I will go for a simple linear fitting. Okay, then here it is in a linear fitting. This is the data and this is a linear fitting. So this line is somewhere coming out because previously, okay. Then this is, sorry, once again I will plot it and then I will go. Sometimes it may show error, it happens to be. And then I will have a grid line. Then go to the tools, look at the data. I want to have a linear fit, I can get a linear fit. It will show you the linear equation. Then I want to see the equation also. Then quadratic fit, it will show you the quadratic fit. Then cubic fit, fourth order. Likewise you can go on adding the orders and it can reach to the 10th polynomial like this. So here one more thing into this, there is one more command in it. So in this one more command, there is a command called as a post rig. This is nothing but a regression we are going to do it. So in regression, what it happens, we are going to plot, we want to fit the curve and how much amount of data is fit. That is R value. That R value, how to determine, we'll look into the curve fitting part of it. So in this case, there is one more, that is what it is called as an interpolant type of fitting. In this interpolant type of fitting, I'll just remove all this. These are the fitting where you are not going to pass from the data points. Then here I can have a spline interpolant. Means what is going to happen? Interpolation means this is my first number, this is second, third, fourth, fifth. All these numbers through which it is going to fit the curve. That is what I'm interpolating. Then another one is shape preserving type. Means it is going to maintain the shape. What are the shape it is going to maintain, and based on that you can fit it. But for these two you will not get the fitting equation. So this is what way you can look at it here. And so you will not get any residual as you are going to pass through all the data points. It is what it works. So you can now determine any value in between it. So I want to now whichever we have determined 11, 22, 33 like this. I want to determine the value of the function at 20. So now I can evaluate it. I want to determine at 40 also. evaluate and it will determine the function. Even you can provide multiple numbers into this, so 1 2 3 4 like this, and it will all these numbers at these all values, it will determine the particular fitting equation. Similar fashion for spline interpolant also you can do it. So in this case I can have on a 10 12 15 25 30 50 75 90 like this. So it will determine all the values for all this for a particular shape. So that is what the way you can, then you can again plot onto this what are the values we have plotted. It will show these plots like this, and this is what a very interesting feature we have seen it in here. And so I will now stop here with this, and later tomorrow again we'll meet for further part of MATLAB. So thank you all. So